Have you ever wondered what life would be like if you could not remember your friends or family? Hello?
Hey honey, it's mom.
Who is this? Or what if you were trying to throw a ball and your hand began to shake? People who have neurological diseases should have a better option and hope at outstanding treatment. Stem cells are that hope. Injecting stem cells has shown to be beneficial in the treatment of Parkinson's disease, multiple sclerosis, and Alzheimer's disease. Alzheimer's disease is the most common type of dementia. It consists of a decline in cognitive abilities and a foggy memory. Neural stem cells with a protein that aids in nerve survival are injected around the hippocampus area of the brain. Then these stem cells aid with nerve growth in the memory area of the brain. Parkinson's disease is a neurodegenerative disorder that causes tremors, impaired balance, and affects voluntary and involuntary movement. Neurologically, it is the degeneration of dopamine neurons. An injection of neural stem cells with an amino acid that helps produce synthetic dopamine is beneficial because it helps produce more dopamine so the symptoms of Parkinson's are lessened. Multiple sclerosis is an autoimmune disease that involves the breakdown of white and gray matter in the brain. It includes a fast loss of brain cells and a quick decline in the brain's ability to communicate. Neural communication is essential for basic functions like eating or moving. High-dose immunosuppressive therapy using bone marrow mesenchymal stem cells is beneficial for patients with multiple sclerosis. Stem cells are unspecialized cells that can multiply to create more identical cells and specialize into any other kind of cell. Imagine holding some Play-Doh. The soft and rainbow Play-Doh that can be molded into anything are like embryonic stem cells. There are 5 main types of stem cells which are divided by levels of differentiability. Totipotent stem cells can specialize and become any other type of cell, so they have the highest level of differentiability. Then we have pluripotent, multipotent, oligopotent, and unipotent stem cells. Stem cells can also be obtained from the embryo, umbilical cord, bone marrow, and the brain. Neural stem cells are self-renewing, multipotent, and able to become nerve cells. Hematopoietic stem cells are blood stem cells. They can give rise to red, white, or any other kind of blood cell. Mesenchymal stem cells are present in many tissues and can differentiate into bone, cartilage, and fat cells. Stem cell transplantation can be useful for neurodegenerative diseases like Alzheimer's and Parkinson's and autoimmune diseases like multiple sclerosis. Multiple sclerosis is a disease where the immune system attacks the healthy central nervous system, destroying myelin sheaths and neural communication. Fernanda Koskett, an assistant professor at Baylor College of Medicine, states that hematopoietic stem cells can help multiple sclerosis through high-dose immunosuppressive therapy. First, the patient's stem cells are extracted from their bone marrow and external stimuli is used to prepare them for transplantation. Then, while preserving those stem cells, the patient's old immune system is broken down through high-dose immunosuppressive therapy. Finally, the stem cells are reinserted back into the patient's bone marrow and the immune system rebuilds itself. It is assumed that since the patient has a new and healthy immune system, that it will not attack the central nervous system, therefore eliminating multiple sclerosis symptoms. The second way to help patients is by using mesenchymal stem cells. These stem cells come from the bone marrow and they reduce inflammation, therefore severed nerves and myelin sheaths have a chance to fix and regrow. Stem cells can be injected into patients with Parkinson's disease to produce dopamine neurons. Dopamine helps with motor coordination and body movement. Since dopamine cannot cross the blood-brain barrier and it cannot be injected into the brain, we use synthetic dopamine called L-DOPA. L-DOPA is directly injected into the brain and helps produce dopamine more quickly. Tyrosine hydroxylase is an amino acid that helps produce L-DOPA inside the body. Jun Takahashi, an expert in neurosurgery, states that with the injection of neural stem cells that have tyrosine hydroxylase neurons, the brain will produce more dopamine so the symptoms of Parkinson's will be lessened. On the more neuro side, induced pluripotent stem cells have only been tested in rats at the National Neuroscience Institute at Singapore. These stem cells are similar to embryonic stem cells because they can both differentiate into any type of cell. But induced pluripotent stem cells are derived from adults. Patients with Parkinson's disease lack dopamine neurons, and once they're injected with induced pluripotent stem cells, they're able to produce the dopamine neurons in rats, which is their first step to their effectiveness in humans. Injecting stem cells in patients can help improve memory and nerve communication for Alzheimer's disease. The cerebral cortex is the outer layer of the brain that we see, which consists of wrinkles. The human nerve growth factor provides instructions for making a protein called nerve growth factor beta, which helps in the development and survival of nerve cells. The Department of Human Anatomy in China affirms that injecting neural stem cells combined with the human nerve growth factor is one form of stem cell therapy. It leads to an increase in healthy nerve cells, which is essential in combating Alzheimer's. Brain-derived neurotrophic factor is a protein that aids in nerve survival, maintenance of nerves, neuroplasticity, and learning and memory. The neural stem cells with brain-derived neurotrophic factor are injected around the hippocampus of the brain. The hippocampus is the part of the brain that has to do with memory storage and processing. This helps in restoration of memory loss. The figure below illustrates how money is being spent on stem cells and incorporates the money being spent on Alzheimer's, Parkinson's, and multiple sclerosis for 2018. The most money is spent on Alzheimer's and non-embryonic stem cell research. Stem cells provide new hope and a more long-term form of treatment for patients with multiple sclerosis, Alzheimer's, and Parkinson's disease. If doctors and researchers have the ability to help, they should do anything to try. In the end, doctors, researchers, and scientists all play a role in saving other people's lives and offering them a better quality of life. That is the ultimate dream. The first question asks why I chose this topic and what about it interests me. I chose this topic because I was fascinated about the brain from AP Psychology and further developed an interest about what happens in the brain and how our brains are different from people who have Alzheimer's. Stem cells intrigued me and I enjoyed researching on this paper and learning more about them. The next question was, what was something interesting about my topic that I did not know previously? I learned about the different types of stem cells and the symptoms of all three disorders. I found high-dose immunosuppressive therapy to be quite interesting because it rebuilds the patient's immune system using their own stem cells. The last question was, how did I grow in this process? Learning the unbearable symptoms about the brain disorder showed me how important it is to value your memory and your life. I truly enjoyed the research process, even though it took me way more time than I expected to find resourceful articles. Thank you so much for watching, and I hope you enjoyed.